Hello everyone, my name is Devansh and today I'll explain you how attention mechanism works. Firstly, I'll give you a brief overview about the attention mechanism. Then I'll go through its history and why it was needed, and then finally I will go through some math. So starting with its overview. So attention mechanism takes a sentence as input, then it processes all the words parallelly and assigns some attention weights to it, and then based on these weights it uh, it measures the importance, and it tends to keep the more important information and forgets the less important ones. So to understand this better, you can take an example you can take a real life example, like when you are in a conversation, you you pay attention only to the important details and omit the less important ones. So this is what precisely the attention mechanism does. So why was it even needed when RNNs and the upgraded versions LSTMs were already being used for natural language processing? So the problem with them was they really struggled with long-term dependencies. That is, when you give a very long input, they would tend to forget what the information was at the beginning. So also they were pretty slow. Like, you imagine reading a book and reading word by word. So to address this, attention mechanism was introduced. So like I have made a table comparing them. So you can see this. And now the most important thing. To know how attention mechanism really works, you need to understand uh, three basic terms. Query. This is the information you are looking for. Like, this is what you type in Google. Then second is the key. It describes the elements in the input. For example, when you type something on the Google, you search it, there are certain links, and below the link there is some brief description about the topic. So this is what key is. And then value. This is the actual data you are interested in. For example, the content of the web page. So attention mechanism calculates how relevant each key is to your query, and then weighs the corresponding values accordingly, and then assigns its importance. Now let's go through some math. So for each query, you have to calculate its dot product with each key to get a score. And this score indicates how much focus the query should give to each key. Like this is the this assigns importance. So this, like in the matrix form, you do q multiply q with k transpose to get dot product. Then you have to scale the scores. This is pretty important because in the dot product you may get some very huge values, and which will cause instability during training. So it will make the training more difficult. So to address this, you have to divide this by the square root of dimensionality of the keys. Then you have to apply softmax. So softmax is basically e raised to the power something upon summation of all e's. So so you so this basically converts the scaled scores into probabilities using the softmax function. This ensures that the attention weights are between 0 to 1, and this softmax function is applied row wise. So, and then you have to compute output. So multiply the attention weights by the values to. So now I'll explain you the back propagation mechanism. So it basically uses calculus, like you have to calculate gradient and all. So you need to know loss function. It represents how well the model's output matches the desired output. And then weight matrices for queries, like there are different sets of weights for queries, keys, and values. So using back propagation, you have to you have to optimize these weights so that you get the most accurate answer. Then gradients, these are simply the derivatives of the loss function with respect to the parameters. So firstly, you have to take gradient with respect to output. So that is dl by d output. So now you have to calculate gradient with respect to values. So this can be easily calculated using the chain rule. We already have del L by del output. So now you have to calculate del L by del V. So you have to multiply del L by del output into attention weights. So you can see I have used transpose here because actually you have to dot product. So in matrices form, when you have to dot product, you have to apply transpose. Like it is how it is. Then you have to calculate gradient with respect to attention weights. So that is del L by del attention weight is equal to del L by del output into V. Now gradient with respect to scaled scores. So gradient of softmax function, you have to take this into account. So this you can see this, and here this delta ij is very important. It is a Kroneker's delta. So it is 1 if I is equal to j and otherwise 0. So this is very important because it it ensures that no future values are taken. So it like it controls the interaction between tokens in the sequence. It zeroes out attention scores for some tokens that are not necessary at this point, and then compute del L by del scaled scores, then softmax scaled scores dot del L by del attention weights. Then you have to calculate gradient with respect to queries and keys. Similarly, you can do this. Del L by del Q is basically this. Now the most important gradient, like you have to update the values of uh, WQ, WK, and WV. So to calculate this, you have to use chain rule. So we have calculated all these values through through chain rule already, and then we just have to multiply it by input to get these values. So the reason why we need to calculate so many gradients before this important one is to use chain rule. We cannot calculate it directly. It depends on so many parameters, and then you have to update the parameters to make it more accurate. Attention mechanism. Here I have imported NumPy. Then here I have defined class, and this variable will hold the dimension of the key vector, which is also equal to query vector, which that will be used to scale the score. So using this function, we will scale the score. Then you can see this step is optional because this step just nullifies mask positions. This becomes important in certain NLP tasks where you have to ignore future tokens. So you will just nullify after using softmax, this value will approach 0. So here I have applied softmax, and this will just improve stability because the values will not get too big. Values will start from 0, so it will be easy. This batch size means that how many inputs it can process at once. So we are using GPU, so it can process parallelly. So this results in faster computation. Then this is sequence length. It is the number of tokens in the sequence. Then here are the vectors Q, K, and V. So at first they are generated randomly, but you can use backpropagation to improve their values, update them. So yes, that's all.